So from this one, you can make a matrix, delta, no, data B, data C, data D. So you're going to have 7, 2, no data, so 0. Second one, 8 for data C, 2 for data B, 2 for data D. For this one, 7 data D, 2 data C, nothing, so 0. And from this side, you're going to have data B, data C, and data D, and it's equal. Before, if we get like negative number, we have to flip it, but in this case, you already flip it to the 0 side, so you just need to put this number. You don't have to flip it back to positive. Because before, why we flip the negative become positive, positive become negative is because we do the calculation on this side. So for this one, you're going to have 37.5 positive. But when you put it in the 0 side, it will become negative. But in this case, we already did that, so we don't have to do it again. So you just put negative 37.5, 0, 37.5. So this is your A, this is your B. So you're going to have A inverse times B. So you're going to get, you're going to have, it's cut off. Yo, so no, it's cut off. I can't see the numbers.
What? Let me see.
You suck. It's cut off.
100 days.
Golly.
So this is what you got. So this is delta B, this is delta C, and this is delta D. Why is it delta? Data.
Data.
Yeah, data. I keep saying delta.
Delta is the
I know, delta is this.
Yeah, this delta.
Yeah, so after you find this 3, you can put it back into your moment equation. So let's do it. I mean, what is your password?
2852.
The whole world knows your password.
Yo, but nobody's gonna take my phone, bro.
Yeah.
I'm gonna have
So for moment equation, for moment B8, if I remember it right, it should be 3 times
K.
gonna be minus 0. So in this case, your data B is negative something. Damn, wait. And B8, 3Ki plus 225. So in this case, you're gonna have 208.9. Keep fit. In this case, they are constant, so you don't have to worry about this. So you just put in negative 5 point. What number we just got? 5 point something. And you put the number into this, you're gonna get this. And for M, BC, MCB, MCD, MDC, 6.8. CD is negative 176.8. 208.9. Negative 208.9. That's what you have. It's all keep feet. So after that, we have to draw our shear moment diagram. Because we have all the force already, all the moment already. Not so force. So for this one, you're gonna have this. For BA, positive. So positive is clockwise. Negative is counterclockwise. Positive is clockwise. Negative is counterclockwise. Positive is clockwise. Negative is counterclockwise. So you're gonna have this way 208.9. B to 8, oh, I'm sorry, B to 8. A to B is 0, because it's a pin. So for this one, 208.9. And you're going to have BC counterclockwise. Negative 208.9, no, if you put counterclockwise, you don't put negative, just a number. So CB counterclockwise, 208.9. C to D, negative. So it's going to be 176.8. And D to C is positive, so it's this way. 176.8. And for D to E, this way, 208.9. Now we have all numbers. Now do the side convention. Positive, 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 no, positive, positive. Now it says 0, A is 0 because it's a pin. So for this one, this way is positive because this is positive, this is positive, this is positive, this is positive. So this one is turning this way and that way is turning that way. So counteract. So this is negative. So you're going to have negative. And this one, how I do it? I feel like something wrong. Positive. This is negative. So this way. Oh, this one is positive. Wait, let me just see what I did. Oh, I know what I did. Because it's impossible to draw moment diagram like this. Because you know, you have a point node, you have distributed node, you have distributed node, you have point node, you have point node. So you know, this is positive, this is negative. That's why you go down here, and you know this is going to bring up, and you have a point node. So it's going to be something like this. Then go down again because this one's negative. Oh, it's positive. gonna bring down here. This is 76.8, and this should be 8.9. Yeah, 8.9, 6.8. And you bring it up again because you have a point here, so it must be n at the point. And bring down again. This one's also 2.1. Yeah, to this goes up to 0. And roll with this. This should be the though. I see what happened. You know what? What is this shit? No, because for this one, it's so hard to draw the moment diagram. So you know what? I prefer to the share moment diagram first. So erase this. Do the share first. For share, you break it apart, so you're gonna have this. You're gonna have. I want to break it apart. Do the same thing. You're gonna have. You draw this. Not too close. Second span. Another. So for B8, doing that way, so you can have this 208.9, and for BC, B to C, that way, so you can have 208.9.
This is the shear, right?
No, this is the moment, but we're doing share.
For doing
Yeah. And for this one is B to C, so this time is C to B, so it's going to be clockwise 176.8. This one's C to D, C to D. Think that way. 176.8. And this one is D to C, D to C, turn that way, so it's going to be this way. 19. And for DE, you're going to have DE turn it this way, so you're going to have turn it this way. So to find a share, for example, you want to find a share here, so you're going to have A, B, so this is A, this is B. So you want to find a share for this one. You're going to take a moment at this point. So you assume when this way is past it, sum the moment at point B equal to 0. You're going to have V turning this way. So you're going to have V times 30, because the length is 30. And you have distributed load, so distributed load, when you convert it into point load, so also turning this way. So you're going to have 2 plus 2 times 30 times 15, half of the distance. So, and you have this moment here, so opposite. So you're going to minus 208.9. So if you do that, your share should be, negative, minus. Okay. So I'm looking for V1. So you're going to have, I'll say no, take the calculator to calculate this for me, because I didn't know for that.
Okay, so
What is that?
it's a 23.04.
23.04, right?
Yeah.
23.04,
0.04.
and it is should be positive, right?
What happened?
It's negative or positive?
It's wait, hold on. This goes on to the other side. I dare see that. Wait, I'll tell you right now. So no, it's a positive.
Positive.
It's
No, it's negative.
no, it's a negative. Negative.
Because you have
Yeah,
to go to zero side,
it's
so
a
it's
negative.
negative.
It's a negative.
If it's negative, that means going down, so it's opposite, so it's going up. So this share is going up, which is 23.04. In this case, if you know the force for this one's putting up this, you can find the force. You can find this force, this share, which is just take this distributed load, convert it into the point load, and then minus this one. So this one should be 36.96. You do the same thing for this one. You sum the moment at this point, you can find a share for this point. And if you find a share for this point, you just take the point load minus this, then you got this. So you do that, you should get 26.96, and this one should be what is this? 23.93. Same thing here. You sum the moment at this point. Just do the same thing. You're going to find a share for this point. And after you find a share for this point, you do the same thing. Point load minus this share. You're going to get this share. So this one should be same thing. 23.93. And this one should be 26.07. 26.07. 26.07. 26.07. 26.07. Yes. And for this one, you sum up the moment at this point, you can find a share for this point. And you find a share for this point, use the distributed load, convert it into the point load, and then minus this share, you can find this share. So this one is equal to 36.96, and for this one is 23.04. So if we have all the share, we can draw our share diagram. So we're gonna have a line. You're gonna have distributed load. So you're gonna have 1, 2 point, 3 point, 4 point, 5 point. You have point load. You have point load. So for share, 23.04. So you're going up 23.04. Distributed load. So you take this minus the distributed load. You're gonna have negative 36.96. At this point, you have this, so you bring it up. 36.96, bring it up to 0, but you have, because this and this at the same, they are at the same point. This share is going up, this share is also going up, so you have negative 36.96, and then you have this 36.96, bring it up, so you bring this to 0, and then you also have to add this one, which is 26.07. So keep going. You're gonna have 26.07. For this one, nothing in between it, so you go to here. But when you hit this point, you have a 50. Keep pointing down. So you take this minus 50, you go down to negative 23.93. But let me see. So you keep going. At this point, you have 23.93 pointing up. So you bring this to 0. And at this point, like I said, they are the same point, at the same support. So you have another shear going up, which is 23.93. So you keep going. So you have positive 23.93. And then nothing, so you keep going. At this point, you hit your 50 kick. So you bring it up, or bring it down to negative 26.07. And then you just keep going. At this point, you have 26.07 pointing up, so bring it back to 0. And at the same point, you have 36.96 going up, so it brings it up to 36.96. And for this one, you have distributed load. So you take this minus the distributed load, it's going to add as, oh no, yeah, wait. Distributed load, 36.96. You're going to bring it right here to negative 23.04. And at this point you have 23.04, so you bring this back to 0. So it's perfect. Then you can do your moment diagram. But before you do your moment diagram, you have to find this distance and this distance. So you can take this as a big triangle. Here to here, you just add 23.04 plus 36.96. So the whole thing should be 60. And this distance is this, so it's 30. And you note at this height, you have negative 36.96. So this distance is 36.96. So you take 60 over 30 is equal to 36.96 over x. So you can find x. So you do that, your x should be so you're gonna have, no, I can't see it. Yo, guys, it's all Chris' fault, I'm telling you.
Yeah, that's
Chris Perez. So you have 18.48, 11.52. So you have the distance. How far? Yeah, stop that. So you do your, you can just calculate it to draw your moment diagram. So for a moment diagram, okay, so moment diagram, 1, 2, 3, 4. Oh no. So for this one, you calculate this area, it's going to be 132.7, 152 or 132. 132.7. And then you calculate this area, so you take this minus this. You're going to have, bring it back to negative 208.9. And then you add this area, it's going to bring it up to, oh no, so you're going to have, oh yeah, this is parabolic and this is linear because you have distributed load and the rest is point load and you have distributed load. So you're going to have 187.2 and bring it down here, so you have negative 17. negative 176.8, and then bring it up again. So you're gonna have 182 or 187.2, and then you bring it back down to 208.9, and then you have parabolic, and this one is 132.7. See, this is your shear, your moment diagram, and for your deflection, you have a pin, you have a roller, ruler. So for this one, positive shows smile face, sad face, smile face, sad face, smile face, sad face, smile face. And the only thing you have to be careful is the when you have this point and this point. This point means when this is the point when you have smile face change to sad face. So you just mark the point. I mean, approximately right here, right here, right here, right here, right here. So when you draw it, smile face. So you're gonna have smile face up to this point, and then become sad face. So you're gonna have turning like sad face like this. Sad face, and then smile face again. And at this point, hit this point, it becomes sad face again. Sad face, then turn to smile face, then sad face again, sad face, smile face to the end. So that's it. That's your deflection shape.
Tell them why it's 0 at the
end.
At the pin. At all the sports, it's 0. Deflection is
There's
0.
no deflection at the sport. That's it. It's okay.
I mean, you should know that.
And study for
It's
example.
a support.
It's
Come on, give your last good luck to everybody.
Yeah, guys. Good luck on your test. Don't call me.